Here is a question courtesy of physics and maths tutor. Wires P and Q, made from the same metal, are connected in parallel across a cell of negligible internal resistance. Wire P has length L, diameter D, and has a mean drift velocity of 0.6 millimeters per second. Wire Q, on the other hand, is 3 times longer and has twice the diameter, therefore 4 times the area, and carries with it a velocity v that we're trying to work out. So first step is always to draw a diagram. I've got P and Q. They're both connected in parallel. That must mean that they have the same voltage across those two resistors, or wires, whatever you want to call them. They also have the same resistivity and the same charge carrier density. And that's because they are made from the same metal. So as I've said, we've got length and we've got diameter, therefore we've got length and area. So this equation pops to mind. Length goes up by a factor of 3, area goes up by a factor of 4, therefore resistance of wire Q goes up by a factor of 3 over 4. Now, if I were to draw this out, I might have one wire, which is 3 times longer than the other, and 4 times the cross-sectional area of the other. Isn't quite to scale, pretend it is. So the point is that resistor Q, or wire Q, is actually of a lower resistance. Because although it's got 3 times the length, it's got 4 times the cross-sectional area. So it's actually 0.75 times resistor P. Now, if the resistance has gone up by a factor of 3 over 4, most of you will probably think, well, the current must have then gone down by a factor of 3 over 4. Just to prove that, there we go. We've got the voltage across both wires as the same. If the resistance goes up by 3 over 4, current must go up by 4 over 3. Now we can plug that all into the equation NAVQ is equal to I. However, many of you will not recognize that equation, so I'm going to change it to a more recognizable ANEV. I prefer NAVQ personally. But there we go. The current, as we've said before, has gone up by a factor of 4 over 3. The area has gone up by a factor of 4. Therefore, the drift velocity must have gone up by a factor of 1/3. So that must mean that wire Q is carrying a current which is 1/3 of what wire P is carrying. And so once you work it out, you find that it's 0.2 millimeters per second. Therefore, the answer is B.